So this is another video on our series on statistics and probability for 7th grade math. Remember on the last video, we talked about the difference between mean, mode, median, and range. Mean, median, and mode are measures of center. The mean is basically an average, which means adding all the numbers and dividing by the number of numbers you have in your data set. So it's the sum divided by the number of items. The median is the actual center value when you actually line up all the numbers from smallest to largest. And the mode is the value that happens the most often. The range is a difference between the maximal value and the minimum value, and that one tells you how spread out the data actually is, and if it's close or far from those averages or that median. When the numbers do all agree, you have a data that's really well centered and not biased, but sometimes the mean and the mode and the median might not agree at all, which could be an indication that there are biases in your data or that a lot of values are pulling your data one way versus the other. Because of something interesting to happen in your data. So it's important to look at them together to actually describe your data, and that's why we encourage students to look at all of them. One way to visualize the occurrence of data in your data point is to show the number of times that each score happens using a dot plot. So what a dot plot is again, it shows the score in each data set. The more times a value happens, the bigger the pile of dots that is placed over that value in the number line. So the dot plot basically shows how often a value happens, and it also shows you how spread visually the data is and the data set, and what parts of the data have more values in it. So for example, here in 6th grade, you can see a gathering of values between 78 and 84, while you see in the 7th grade, a bigger gathering happening between 84 and 88. So that alone tells you that there's a substantial difference between what 6th grade and 7th grade is doing in these test scores. Now, dot plots can also be used to determine the mean, the average, the mode, and the range, because all the values in the data are here. So for example, in the 6th grade, if you're trying to figure out the mode, all you have to see is the tallest column, and there's your 80. In the 7th grade, that would be 88. To find the average, you will literally list all these numbers and add them all up together, and then divide it by the numbers you get. And you would get 83.83 as the mean for 6th grade. But when you could do that for the 7th grade, again, you add up all the numbers listed and divide it by the number of items, which is 12, you get a mean of 87. So comparing those two means already suggests, it looks like the most of the students are getting better scores because the average is higher on the 7th grade. Remember, I said that could be biased. You could have a lot of students scoring really high, and then that can change the way the data looks. So that's why it's important to not only look at the mean, but looking at all of them together. Now, if you look at the mode, it is also common that you have 3 88s on 7th grade versus 3 80s on 6th grade. So there's another piece that agrees that the 7th grade seems to be doing better in scores in that case. Then if you look at the median, which is the center value, again, you have to list them all in order and then find a value at the center. Since this is a data set with 12 values, it would actually be adding the two numbers near the center and dividing it by 2. So in the case of 6th grade, it's between the 80 and the 82. So that's going to be 81 for your mode. And for the 7th grade, it's going to be between 86 and 88. So 87 would be your mode. So once again, comparing the modes shows that the 7th grade still is doing better, right? So all three agreeing kind of show you that the 7th grade is significantly scoring higher than the 6th grade is. Another way that to look at this that's interesting, though, is that if you look at the mode, the median, and the mean together. So the median is 87, right? And the average is also 87 for 7th grade, and the mode is also 88. So the fact that they all agree means that the values aren't biased to one or the other side of the data set. There are just as many to the right of that average and to the left of that average, or higher and lower than that. And that's why they tend to agree. The data is well centered, right? The average is near the middle when they agree. But if you look at the 6th grade, you have 80, 83, and then 81. So they are close, but not as close as the 7th grade numbers were. And then you can see that bias. You see that there's a shift towards the left. There was more values to the left of the average, which is 81s, than to the right of the average. And that's kind of what looking at all of these numbers together can reveal, right? Now, if you look at the range of values in the sixth grade was 22. So the lowest grade was a 74 and the highest grade a 96. So there's a really big range in values. But the same range happens in the seventh grade. So that indicates that the values are not necessarily more spread out in the seventh grade than they are in the sixth grade. But even though the spread is the same, the whole thing is shifted on seventh grade to higher values, since the mode, the medium, and the mean are all higher than the sixth grade values. All right, so all of these different pieces of analysis are possible by looking at those measures of center, and it's visualized in a dot plot, which is why it's so cool to use it. There's another plot that shows something similar, which are box plots, but that is considered even better as showing the spread, because when you have a very centered data, it will look like this. The medium is going to be right at the middle between the minimum and the maximal, and you have the size of the box, which are defined by the quartiles, at the also evenly distributed throughout the range, right? So you have these blocks that have even spacing. That means that numbers are spread throughout the data set evenly, if it looks like that. But a lot of real data sets don't look like that. So let's talk about what each of these things are. We already talked about what the minimum and the maximal are. We talked about what the medium is, which is the center value when you line up in size. We did not talk about this idea of the first quartile and the third quartile. So what you do to find Q1 is you would imagine that the entire data set does not exist past the medium. The medium now became the maximum, right? So you're looking at only the bottom half of your data, and then find the medium again. So basically, the Q1, or that value that separates the quartiles there, is the medium between the minimal and the medium. So it's the center number, if you line them up in order, between the minimal and the medium. Likewise, Q3 is the center number between the medium and the maximal. So if you line up the top half of your scores, list them all up, it's the number between the middle medium and the maximal, the number in the middle, right? So then that creates these edges here. And the interquartile range is just the range between Q1 and Q3. Now, in seventh grade, you're not going to be asked to create box plots, but you might be asked to kind of see what they actually mean. So it's more useful than defining these terms to talk about what they mean. The medium, remember, is the value at the middle if you line them up by order, which means half the values are above it and half the values are below it, right? The quarter one is the middle of that lower range, and so that means 25% of values are below it and 25% of the values are above it. And Q3, 75% of values are above it, because all of these would be above it. And for Q3, 25% of values would be above it and 75% of the values would be below it. And that's what they mean by quartiles, right? So the first quartile is where the first 25% of the values lay. The second quartile is where the second 25% lays, and that makes up, from the minimum to the medium, 50% of the values. And then the third quartile is the next 25%, and the last quartile is the last 25%, making up together the 50% above the medium. Okay? So now, the whisker, by the way, is this section that's outside of the main box, where you will find the values which are closer to your medium. And those are the values that are also probably most likely closer to the average. Now, when your data is well-centered and your average and mean and mode all agree, for the most part, then your box plot is going to look very even like this. But whenever the average and the medium don't agree, you're going to start seeing shifts in the box plot, as you see in this example. So the fact that it's not evenly distributed, the quartiles are not all the same size, that means that the numbers, the average and the medium, are definitely not going to agree. So if you look at this example, by the way, you can actually pull out the numbers from it. You see how the basketball minimal is 73, while the maximum is going to be 83, which means the range is going to be 10. Now your medium is a 79.5, so between 79 and 80, and your Q1 is a 79, and your Q2 is at 80.5. Now, remembering what this means, 50% of the values are below this number, and then 25% of the values are below this number. What this is telling us is that a lot of values are actually spread out across this entire piece of this whisker here. And then a whole bunch of values, another set of 25%, so a quarter of your numbers are all clustered right here, just below your median. Then you have another quarter of your numbers clustered above the median, but a little more spread out. And then another cluster of a quarter of your numbers above even that, but less spread out than they were here. So the first quartile is super spread. So the shorter basketball players are all over that spread. But then you have 50% of them clustered between 79 and 80.5 inches. So most of your players then are going to be in that small range. So that's kind of what shows you that why the box plot is so awesome, because it actually shows you where most of your data is hitting it. And among the 25%, which are bigger than that, there's less of a spread than among the shorter ones. Now, when you look at the volleyball numbers, the minimum is 72 and the maximum is 81, which is a lower range. So the whole thing is shifted to the left a little bit because there are more short players apparently in volleyball teams. Now, the median is just below the median for basketball players at 79. But then if you compare the fact that where 50% of all the players are, which is inside of that box, most of them are spread from 76 to 81, which is much more of a spread than the spread of most of the basketball players. And the part that's below average is more spread out than the part that's above average, or above the median is actually what I meant instead of average, because this does not show averages, it shows the median. In fact, it is impossible to figure out the mode and the median by looking at these plots. The only thing you can figure out from a box plot is the distribution of data. Now, what is really clear by comparing them, and that's kind of question you're going to have to actually deal with, is that the numbers of the basketball players tend to be higher than the numbers of the volleyball players. The entire thing is shifted compared to the volleyball. The median is higher, and 50% of the values gather close to that median, while the 50% of the basketball values are spread more and lower than the ones in the basketball team. So that means overall, they're going to be way clearly taller on average on the basketball. So see, even though the average is not in a box plot, you can infer that that's the case. But you can also tell that because this is not evenly distributed, the little quartiles are not evenly distributed like we saw in the example above, then we know that the average and the mean are not going to agree. There's no way that that's going to be the case. But it's going to be closer in the basketball players because a lot of them are clustered near that middle when compared to the volleyball players where there's more of a spread. So that is the box plots and dot plots, which are different diagrams used to describe statistics based on those descriptive statistics that we talked about in the previous video. Don't stress too much. All you have to do is be able to look at the diagrams, and in the case of dot plots, actually extract things like median, mode, and mean and range from it, and kind of tell how the groups compare to each other. And on the box plots, you don't really need to understand the quartiles and things too much. You just have to basically look at it and be able to tell how do they compare. And you look at that by looking at the spreads and where the medium is and how close to the medium the values are in the box, and these little hints that I gave you in this video. But we are going to do more practice of that on the next video, where we're going to do a workshop practice looking at questions from the actual test or similar to the ones in the actual test that will show up. And so hopefully that will make all of this clear, and I'll see you guys then.